Let's do some problems involving permutations and combinations. How many ways can a president, vice president, and treasurer be chosen from 6 people? So first, we have to ask ourselves if this is a permutation or combination problem. In other words, does order matter or does it not matter? So we're choosing a president, vice president, and treasurer. And we have, let's just call our people A, B, C, D, E, and F. So one way that you could choose a president, vice president, and treasurer from those 6 people would be person A as president, person B as vice president, and person C as treasurer. So if you choose these 3 people and flip the order or switch the order up, does it matter? Yes, because if you had person B here as president, person A as vice president, and person C as treasurer, then that would be the order matters because you have different people in different positions. So that's how we know this is a permutation problem. Okay, so let's think about how many ways we can choose a president. Since there's 6 different people, there are 6 different ways that we could choose a president. And for each of those 6 different ways we could choose a president, there are 5 ways that we could choose a vice president. Because let's say we chose A as president, then you could choose B, C, D, E, or F as vice president. And if you chose B as president, you could choose A, C, D, E, or F as vice president. And this repeats for all 6 presidents, or all 6 potential presidents. So that's why, in order to get the total number of ways that you could choose a president and vice president, you would multiply these together. And then for each of those 30 ways that you can choose a president and vice president, there are 4 ways that you could choose a treasurer. Because if you've already chosen 2 people, then there's 4 remaining people to choose from. So in total, the total number of ways that we could choose a president, vice president, and treasurer from those 6 people would be 6 times 5 times 4, which is equal to 120. Okay, and I know there's also a formula for this. It's n factorial over, you probably already know it, over n minus r factorial, where n is the number of people that you're choosing from, and r is the number of people you're choosing from, and r is the number of people that you're choosing. So in this case, we're choosing from a pool of 6 people, and we're choosing 3 people. Or this doesn't always have to be number of people. It's just number of things that you're choosing from, and number of things that you're choosing. So let's see if this formula, we could have used this formula also to solve the problem, but I just wanted to give you an idea of what was going on. So in this case, we would have 6 factorial over 6 minus 3 factorial, which is equal to 6 factorial over 3 factorial, which is the same as 6 times 5 times 4 times 3 times 2 times 1 over, sorry about, it's hard to see. Okay, over 3 times 2 times 1. So, because that's 3 factorial and 6 factorial. So in this case, the 3's would cancel, the 2's would cancel, and the 1's would cancel, and you'd be left with this 6 times 5 times 4 right here. So we arrived at the same answer without using the formula, but obviously on the test to save time, you could just do this, MPR, on your calculator, but it's good if you understand what's going on apart from the formula. So yeah. Okay, let's move on to the next problem. So we're going to switch it up a little bit. How many ways can a committee, oops, I don't know if I spelled that right, committee of 3 be chosen from 6 people? Okay, so in this case, would order matter? So let's just say our people, same people, A, B, C, D, E, and F. So in this case, since it says committee of 3, and there's no specific positions, if you were to choose A, B, and C for the committee versus B, A, C for the committee. Both of these committees are still the same committee because it's still the same 3 people in the committee. It's just a different order. But in this case, since there's no specific positions, order does not matter. So that's how we know we have a combination. And we know that the formula for combinations is n factorial over r factorial times n minus r factorial. So we could use the formula, or you could just plug it into your calculator as NCR. In this case, since there are n people that you're choosing, or since there are 6 people to choose from, 6 choose, and you're choosing a committee of 3 people, it's 6 choose 3 in your calculator, and that would get you the answer. But at the same time, while we know the formula and how to get it on the calculator, I also want to show you guys like some of the intuition on why the formula is this right here. So first of all, let's just pretend like order does matter. So if order does matter, we know that the number of people, the number of ways that you could choose these 6 people would be 6 times 5 times 4 from the last problem that we just did. So that's assuming that order does matter. And then if we assume that order does matter, then we're basically repeating for every single case, for every committee, we're repeating the committee several times. So for example, if you have a committee of, let's just say if you have a committee of persons A, B, and D, we have to ask ourselves, how many times can we repeat this committee? Because obviously BAD is the same as ABD. So in this case, you could have ABD, ADB, you could have BAD, you could have BDA, you could have DAB, DAB, and DBA. So in this case, there's 6 ways that you can repeat the same committee. There's 6 different ways. And you could have figured this out just by doing 3 times 2 times 1. Because, yeah, so 3 times 2 times 1 is the number of ways that you could repeat this committee. So with that in mind, if you have 6 times 5 times 4 permutations, and you don't want any you want to choose a committee of 3 people without any repetitions, you have to divide by the total number of times that you could repeat for each committee. And we just figured out for every committee that you choose, you can repeat. There's 6 possible repetitions. So in this case, these 6's would cancel and you get 20. And this is the same as the formula because if you think about it, n factorial would be 6 factorial over r factorial. R is 3. 3 factorial times 6 minus 3 factorial. That's equal to 6 times 5 times 4 times 3 times 2 times 1. I'm not going to put that there though. Over 3 times 2 times 1 times 3 times 2 times 1. Because this 6 minus 3 is just 3 factorial times 3 factorial. So in this case, the 3 times 2 and 3 times 2 times 1 would cancel. And you'd be left with 6 times 5 times 4 over 3 times 2 times 1, which is 6. So as you can see, you can arrive at the answer by thinking about it conceptually, but the formula just gives you a shortcut way to do it.